Hi boys and girls. Today I'm going to teach you a 6th grade lesson. This is grade 6, module 5, lesson 11. We are going to be finding volume with fractional edge lengths and unit cubes. Let's begin. This problem says the dice are 1/2 inch by 1/2 inch by 1/2 inch cubes. How many dice of this size can fit in the box? Well, to figure that out, we have to think about those 1/2 inch dice right along this line right here. So if we have a 1/2 inch dice, we can count there's 1/2 inch, 1 whole inch would be 2 dice. So we have 10 inches, and if 1 whole inch has 2 dice, we can do 2 times 10, and that gives us 20 inches. So that's going to be our first number there. There's going to be 20 along this bottom section. Now in the 4-inch section here, again, we still have 2 dice that make 1 inch. So 2 times 4 is 8. And then we have this height. So we have 2 dice in 1 inch again. So 2 times 6 is 12. So in order to find the total number of dice that can fit into this box, we need to multiply 20 times 8 times 12. 20 times 8 we'll do first. 8 times 0 is 0. 8 times 2 is 16. And 160 times 12. 2 times 0 is 0. 2 times 6 is 12. 2 times 1 is 2. Plus 1 is 3. Placeholder going into the tens place. 1 times 0 is 0. 1 times 6 is 6. 1 times 1 is 1. We add these together, and we get 1,920 cubes. So how many dice can fit in the box? The answer is 1,920. Sorry, that's messy. That's better. So 1,920 dice can fit in the box. So some of you might be saying, well, what does that have to do with the volume? So we know that the volume equals the length times the width times the height, which in this case would be 10 times 4 times 6. I know 10 times, actually let's do 4 times 6 is 24, and 24 times 10 is 240. So the volume of this figure is 240 cubic inches. Now, how do we relate these two numbers? There's 1,920 dice that can fit in the box, and the volume of the box is 240 inches. How do those two numbers relate? Well, if we have a 1/2 by 1/2 by 1/2 inch cube, 1/2 times 1/2 times 1/2, 1/2 times 1/2 is 1/4, and 1/4 times 1/2 equals 1/8. So the cubes, or the dice, are 1/8 cubic inches. So if we take the number of dice, 1,920, and we multiply it by the 1/8 cubic inch cube, we are going to get, or we should get, 240 cubic inches. So let's do 1,920 over 8. 1,920 divided by 8. 8 times 2 is 16. We get 3. Bring down the 2. 8 times 4 is 32. We get 0. Bring down the 0. 8 goes into 0. 0 times. There it is. So that's how these two numbers relate. So 1,920 dice can fit in the box, and the box has a volume of 240 cubic inches. Let's follow that same procedure for this problem. So this one says a 1/4 inch cube was used to pack the prism. So now let's look. Along this 1.5 inch length here, we know that we have to fit a 1/4 inch cubes. So how many 1/4 inch cubes would fit in one hole? So if I have 1/4 and then another 1/4, that's 2 quarters, 3 quarters, 4 quarters. So there's 1, 2, 3, 4 quarters in one hole. And how many in a half? Well, I know 2 quarters is equal to 1/2. So I have 1, 2, 3, 4, 5, 6 that would go along the length. And I know that 4 quarters equals 1 whole, so 4 would go along the width. And I have 3 3/4 in the height, so that would be 4, because we have 4 units equals 1 whole, times 3, which is 12. And then I have 3 more, 1, 2, 3, 13, 14, 15, so the height would be 15 cubes. So 6 times 4 times 15 will tell us how many cubes it will take to fill the prism. So 6 times 4 is 24, and 24 times 15 will tell us how many cubes. 5 times 4 is 20, 5 times 2 is 10, plus 2 is 12. Placeholder, 1 times 4 is 4, 1 times 2 is 2. I get 360 cubes will fill the prism. Now, what is the volume of this prism? Well, we have volume equals length times width times height, which is 1.5 times 1 times 3 3/4. We know when we multiply mixed numbers, we have to change them to improper fractions. So 2 times 1 is 2, plus 1 is 3, so this is 3 halves, times 1, times 4 times 3 is 12, plus 3 is 15, so we have 15/4. So 3 halves times 1 is 3 halves. We have to multiply by 15/4, and we get 45 over 8, and 45 divided by 8. I know that 8 times 5 is 40, and I get 5 left out of 8. So my volume is 5 5/8 cubic inches. How do these two numbers relate? The 360 cubes and the 5 5/8 inches. Remember, each cube is 1/4 by 1/4 by 1/4. Let's figure out what the volume of each cube is. 1/4 times 1/4 is 1/16, and 1/16 times 1/4, 16 times 4, is 64. So each cube is 1/64 cubic inches. So if we take our 360 and we multiply it by our 1/64, what do you think the answer is going to be? If you said 5 5/8, you're right. So we have 360 over 64. I'm running out of room here. Squeeze it in here. 360 divided by 64. So 64 times 5, since I'm going to guess that it's 5, like this. 5 times 4 is 20. 5 times 6 is 30, plus 2 is 32. So I have 320, and I have 40 left out of 64. And if I simplify by dividing by 8, 40 divided by 8 is 5. And 64 divided by 8 is 8. So my answer is 5 5/8 cubic inches. And that's how the 360 cubes that will fill the prism relates to the volume of 5 5/8 inches. So now we're only going to calculate the volume of the following prisms. Volume equals length times width times height. So I have 2 3/4 times 1/2 times 1 1/4. So I have to change to improper fractions in order to multiply. 4 times 2 is 8. 8 plus 3 is 11, so I have 11/4 times 1/2. I can go ahead and solve that right now. I have 11/8. Then 4 times 1 is 4, plus 1 is 5. So I have to take 11/8 and I have to multiply it by 5/4. 11 times 5 is 55. And 8 times 4 is 32. Now if I divide 55 by 32, I get 1 and 23 over 32 cubic centimeters. Let's try one more. Again, volume equals length times width times height. I have 3 1/3 times 3 1/3 times 5 2/3. 3 times 3 is 9, plus 1 is 10, so I have 10/3 times 10/3 times 15 17/3. And 10/3 times 10/3 is 109 times 17/3. I have 1,700 over 27. And if I divide that, I'll get my answer. I'm going to save a little time here, and I'm going to do 27 times 6, which is 162. When I subtract, I get 8. I bring down the 0. 27 goes into 80 2 times. 27 times 2 is 54. And you subtract and get 26 out of 27, and that's cubic inches. So the volume here is 62, and 26 over 27 cubic inches. So boys and girls, what I'd like you to do is calculate the volume of this rectangular prism and bring this back, and we'll go over it tomorrow. Thanks for watching.